Right, this is the fourth and final session on specialist training methods, and this session is going to focus on SAQ. I'm hoping you've heard of it, you've certainly experienced it sometime, but to be absolutely clear, stands for speed, agility, quickness. Now, speed, agility, quickness training is essentially a program of progressive exercises using hurdles and ladders to develop basic motor abilities, and it's designed essentially to improve our ability to complete skills at a faster pace but with accuracy. So we're focusing on type 2X muscle fibers, but actually attempting to improve a quality that we wouldn't normally associate with them, because we would see fast twitch motor units being employed for growth skills rather than fine. But essentially when it comes to being agile, when it comes to quickness, we require a certain fluency and a certain control that enables us then to perform in that way. So during this exercise session, we can also recognise that there is a leaning towards plyometrics, and in particular the stretch shortening cycle, which we'll explore in a second, but also there's a really nice link to information processing from skill acquisition, which we'll explore in a while. So what do we mean by each of these individual segments within SAQ? Well, speed is the rate at which we complete a task. Now that can be anything, any task at all. It can be the speed at which you complete 5 chest passes. It could be the speed at which I complete 5 keepy-uppies. It could also be, which we're going to concentrate on a little bit more, the speed at which I complete 100 metres. Okay, so speed is the rate at which I complete a particular task. Agility is the speed at which I can change direction. Okay, so changing direction at speed. And finally, quickness. Well, quickness is about the fluency of the movement, the way in which we can control multiple changes of direction. Okay, so it's very much geared in that essence towards accuracy, which we're going to talk about a little bit later. So that's what it is. Use of hurdles and ladders designed to improve basic motor skills, but also to improve our ability to complete those skills at a faster pace, but with accuracy. So first and foremost, we're going to look at how SAQ attempts to improve speed, and it attempts to do it in 2 ways. One, improve power. And this is where it takes advantage of the stretch shortening cycle that we see in plyometrics. Okay, so how does it do that? Well, SAQ, in the use of hurdles and ladders, is essentially attempting to increase the amount of force you can apply on the ground. So if we just focus now on sprinting and we focus on actually moving through these hurdles on foot, these are my feet, okay, looks a bit odd, you have to bear with me, don't get distracted. But what I'm trying to do is improve or increase the amount of force I can push off with. So I'm trying to improve the amount of force that can be applied by my gastrocnemius through the foot onto the ground. Now that is known as your ground reaction force. So essentially that's what I'm trying to improve. So how do I do that? Well, I do that in combination with another element needed within SAQ, and that is that when I hit the ground, I'm attempting to spend as little time in contact with the ground as I possibly can. All right. So as I'm running through, and again, it's going to look a little bit odd, but bear with me. As I'm going through the hurdles, I am not only trying to push off as hard as I can, but also when I hit the ground, when I land, I'm trying to limit the amount of time I spend in contact, that foot spends in contact with the ground. Essentially what is known as my contact time. And so what I'm trying to do is I'm trying to move through as quickly as possible. Okay, so how do we use the stretch shortening cycle then to increase the amount of power that I can exert on by the gastrocnemius when I'm driving off? Okay, and I do that through the power, the force that I apply to the ground. Well, it comes down to the idea that actually in order to reduce my contact time, I actually have to land only on the balls of my feet. Now when my foot is landing, my natural reaction would be that my whole foot eventually will land on the floor. Well, we're going to try and stop that, because if I allow my heel to land, I'm actually increasing the amount of contact time, the amount of time I'm spending on the floor. So what prevents my heel from hitting the floor? Well, my gastrocnemius. Now we know that gastrocnemius, its concentric phase, is actually plantar flexion, so pointing the toe. But in this instance here, when I land, obviously with the heel now moving towards the ground, that's now dorsiflexion. So what the gastrocnemius is doing is controlling that movement to stop the heel from hitting the floor, okay? It's the eccentric phase that we looked at plyometrics. So there's my eccentric phase, so the gastrocnemius is stretched, there's an eccentric contraction, so it's lengthened, but it's provided force to prevent the heel from hitting the floor. Now, I've got a short contact time. So literally, as soon as I'm hitting the floor, I'm looking to drive off again. There's my amortization phase. So the amortization phase is really, really short. So I'm attempting to really make use of the elastic energy that's being stored in that stretch element in the eccentric phase, so that when I drive off in my concentric phase, I have a lot of elastic energy that is being released. So that's how I improve power. So it's not quite as obvious, not quite as violent as we might see, if you like, although don't use that word in your essays, as plyometrics, but we're still capitalizing on the stretch shortening cycle to improve the power of the fibers of the motor units within the gastrocnemius, so that I can drive off. Now, the more powerfully I can drive off the ground, the quicker I'm going to be able to move. The second thing is a bit more neurological, and that is improves something called brain signal efficiency. Now, we know that one of the key characteristics to the type 2X muscle fibre and motor unit is the high transmission of action potentials. What SAQ attempts to do is to improve the efficiency of that even further by being able to deliver those action potentials at a faster rate. And it does so by creating stronger pathways. And when we talk about pathways, you're not going to write it like this, but I'm just going to try and create a picture here so you can see you're almost creating a super highway. So the more repetition you do of a particular action, and in this instance here, in using the hurdles, actually just going through hurdles, the more that you repeat an action, the stronger the pathway from the motor neuron pool up here through the central nervous system and into the muscles that are being used for that particular action. In this instance, the gastrocnemius. So if I can improve the efficiency, the speed at which those action potentials have been delivered even further, then obviously then there is a faster contraction. And if my muscles can contract faster, that is going to improve my speed. In addition to that, so if I put that one here, in addition to that one, I'm going to reduce reaction time. Now, we talked about that in information processing. You know, ways in which we can improve speed is actually reducing reaction time. So how do we reduce reaction time? By improving the brain signal efficiency. If I'm delivering now impulses at a more efficient rate into those motor units, and then my muscles can contract faster, I've reduced my reaction time. And if I'm an 100-metre sprinter at the start of a race, and I've got a far greater rate of transmission of action potentials into my gastrocnemius at the beginning, I'm going to react quicker to the gun, I'm going to be out faster from the blocks, and I'm going to be quicker overall than I would have been had I not gone through SAQ. Now, if we can just come back a sec and we can look at how improving power and obviously reaction time will help, it's worth noting at this point, if you're ever evaluating the SAQ for a sprinter, for example, that actually working alongside resistance training is really beneficial. Okay, so a sprinter wouldn't necessarily just use SAQ to improve the power, to improve the brain signal efficiency of delivering those action potentials to the muscle. They would use it alongside resistance training. That would have a hugely beneficial effect. So it's worth mentioning that if you're asked an evaluative question. So that's speed, but what about agility and quickness? And I'm going to lump those two together. Well, I'm going to come back to the brain signal efficiency. Because brain signal efficiency is absolutely critical also in the ability to be fluent in the movement and the ability to be accurate in the movement, because I have to deliver the right amount of impulses at the right time, because essentially I want to ensure that I apply the correct amount of force. Okay, and we looked all the way back at summation, ways in which we can manipulate the amount of force we apply, and ultimately the more force we need, the larger and more powerful motor units are employed, are recruited. Well, this is why it's so important at this point, because actually I want accuracy of movement, I want speed in my change of direction, but I also want fluency, I also want accuracy, and that separates those elite athletes from the also-rans, as it were. So how does this help in this instance? Well, we improve something called kinesthetic spatial awareness. Now, kinesthetic spatial awareness comes into two parts. The first part is the ability to navigate space. Okay, the ability to navigate space. So when we talk about changing direction, we are navigating space, understanding where we can go. So if we're dodging in rugby, for example, dribbling in football, attempting to dodge into space in netball, wherever it might be at this point, we are essentially trying to navigate space. So if we look back at information processing and we look at proprioception in particular, there are two ways that SAQ attempts to try and aid us in this quest, as it were. First part is it works on touch, the amount of pressure to allow us to turn. So as well as going in this straight direction, I can also do ladders sideways. I can also come up a ladder and then quickly come out to the side and then start going forwards again. But ultimately what I'm trying to do every time I'm changing direction is I'm altering the pressure, the touch, where I'm applying my feet. So if I want to move this way, there's going to be a greater pressure on this outside foot. And we looked at it in skiing, but there's no difference in this element here. So by able to navigate space fluently, actually I'm enabling an improvement in touch, in my pressure, but I'm also improving equilibrium, okay, that balance. All right, so as well as obviously applying the correct amount of pressure, I'm also able to maintain balance so I can fluently move into another direction. Now, as well as navigating space, it also shows awareness of movement. So as well as considering where I've got to go and the pressure I need to apply for that and the balance I need to hold, obviously at that point you need to recognise that we need to be delivering the right amount of impulses into the right areas, into the right motor units to allow that change of direction to occur fluidly. And that comes from kinesthesis. So the three elements of proprioception here are being worked by SAQ. That touch, that pressure to change direction, the maintenance of balance, of equilibrium as I'm going through that, but also recognising the awareness of the movement and the amount of force that needs to be applied. Okay, absolutely critical. And then on top of that, we would expect is that it improves coordination. If I'm being more efficient in the impulse, if I'm sending the right impulses to the right motor units based on the decision that's been made, then ultimately my coordination is going to be better. I'm going to be providing the right movements at the right time. So all of these then have a huge impact then on an individual. Now if we look to the games player, we would say SAQ is absolutely crucial. But what I'm going to ask you to do is I'm going to ask you to look at a sprinter. Now over the last couple of sessions I have really set out the kind of extended answer question, the what, the how, and then the why. I've shown here the kind of how it improves things, both in terms of speed and agility and quickness. What I'm going to ask you to do now when you come to your evaluation is to really consider why these might be of benefit to the individual in the question. All right, and that's what this next stage comes down to. Okay, enjoy.